This video will illustrate how we can use Gephi to analyze individual associations with social groups and make recommendations based upon these groups. This analysis will be completed by using a data set of the relations between Marvel superheroes. The first step in this process is to download both the platform Gephi and the GDF file Comic and Hero Network. Once the programs are downloaded, pull up Gephi, go to the file and open Hero Network file. You should initially see what looks like a black square. This is the collection of nodes which represent the heroes of the Marvel Universe and the comics they appear in. The lines in between them are called edges, and they are intended to draw relationships between the heroes and the different comics that they are in.
Go over to the Data Laboratory tab and you should be able to see the different nodes and edges that are appearing in this set. Note that all these edges are undirected, so there's no directionality in which these are connected. Flip back over to the overview, and the first step in the analysis will be deciding the layout of the nodes. In this video, we will use the Force 2 Atlas layout. This layout will allow the connected nodes to be drawn together and the unconnected nodes to be pulled apart. This will exaggerate the relations between the nodes and make a clearer picture for analysis. When the nodes stop moving, click Stop on the Run button. Then, next step in the process is to run statistics on the graph to create different metrics to filter on in the graph. Run the average degree, the weighted degree, modularity, and the average path length in the Statistics tab. The average path length may take a decent amount of time because there are many relationships in this set. Flip over to the Data Laboratory tab and see the different columns that have been created.
Next, we will start identifying and highlighting key aspects of the graph to help with analysis. We will start with the appearance of the nodes. Go up to the Appearance tab and choose the Color by Ranking option. Choose Degree Attribute to rank by, and choose a color to rank by. Next, navigate over to the Size by Ranking. Choose Degree and set minimum to 0.5 and maximum to 400. Navigate over to the Layout and check the box that says Prevent Overlap in order to space the nodes out. As the graph shows, the nodes are now distinguished by the number of connections they have, by size, and by color. The next step is to separate the nodes more into families or groups by modularity. The modularity class will separate each hero into a class based on the strength of their connection to each comic. Go back to the color selection for each node and select Partition by Modularity class. Here on the graph, we can see the different communities of heroes and how closely they're related to each other based on modularity class, degree, and edge weight. We now want to add labels to the large modularities to see the different groups they're split into. Labels should be very small and jumbled. We will now rank them according to the size in order to clean up our graph.
Navigate to the Nodes icon in the Appearance box and select the Text icon. Rank each node text by degree and set minimum size to be 0.001 and maximum size to be 6. Now we will filter some of the small aspects of the graph in order to make the most prevalent aspects stand out. Click the filter box and locate the topology folder. Click degree range and drag it down to the queries box. Set the lower limit of the degree range to be 43. This will allow the excess information to be removed and the smaller comics and characters not to be shown. We can see distinct groups of heroes that are represented here and how closely they are associated with each other.
Now we can see the various groups of comics and how closely related the groups are. For example, Spider-Man comic characters also appear in the Captain America comics, but not in the X-Men comics. You can also see the outlier comics that are produced but have no connection to other heroes. You can see how this is very useful in analyzing groups of people in the real world and how to capitalize on trends. This application can be impactful in analyzing social media data when determining the connections of different individuals on the site, especially when it comes to recommendations and potential connections.